The correct order of rate of diffusion of the given gases at 27 degrees Celsius is, if I talk about rate of diffusion, that is inversely proportional to root of molecular mass of the gas. It means heavier is the gas, less would be the rate of diffusion. So here we have the gases helium, hydrogen, oxygen and CO. Let me arrange them in the increasing order of their molecular masses. So if I talk about hydrogen, it would be at the first position. Then with the least molecular mass, then there would be the turn for helium. Then CO would be there, and after that there should be oxygen. This is the order of increasing molecular mass. So on the basis of this, the correct order of decreasing rate of diffusion would be, I'll just write here that rate of diffusion for these gases would be maximum for hydrogen, then would be the turn for helium, then CO and then O2. This was the order of molecular masses. So finally order we have obtained here, and this order is correctly given here in option 3. So just choose option 3 as your correct answer. After this, question number 52. Which among the following can exhibit tautomerism? In case of tautomerism, if you look at, these all are the keto compounds and they can be changed into their enol form if they have hydrogen atom at alpha position. If you look at the compound given at the second position, this compound has this keto group, and from keto to this, if we consider this alpha carbon, there is no alpha hydrogen atom present, while at this carbon, if you check, this is bridged headed carbon and it will not provide alpha hydrogen to this keto carbonyl group. That is why it cannot be changed into enolic form. It cannot show tautomerism. While if I talk about this compound, there is the carbonyl carbon, this is oxygen, and alpha to this carbon is present here, at which hydrogen is present as alpha hydrogen. It can easily be changed into its enol form. Further, if I talk about this compound, here we have this keto group and there is an hydrogen atom, and that can be result in enolic form. So on that basis, which among the following can exhibit tautomerism, then your answer should be 1 and 3. Where this 1 and 3 is given, that is given in option 4. So just choose option 4 as your correct answer. After this, question number 53. Which of the given biphenyls can be optically active? Asymmetric compounds should be these. So if I talk about biphenyls of the structure, this is biphenyl, you know, and if some bulky groups are present in this way, here, this way, such type of biphenyls are optically active. And one more thing, these BA and B are some bulky groups. Just choose this type of biphenyl in the given options. If I talk about the first one, we have CH3 and NO2 present here. Here is also CH3 and SO3, and it is not following this type of structure. Further, in option 2 you can clearly see SO3 is here, here also, NO2 is here and here also. It means it is following the given structure. It is asymmetric also. It can show optical activity. In third option, these rings are in the same plane, while in other options rings are in perpendicular plane. This will not show optical activity due to its symmetry. Similarly, if I talk about the fourth option, NO2 is present at the same side of biphenyl. Similarly, CH3 is present at the same side of biphenyl. That's why it will also not show. So only option 2 contains the biphenyl that is showing optically activity. So the answer becomes option 2. After this, question number 54. Equal number of sigma and pi bonds are present in. First we have CH2. If I talk about CH2, the structure is this. One sigma bond here, and one pi bond this side and one pi bond this side. It means it contains equal number of sigma and pi bond. Similarly, if I talk about C2H2, acetylene, there is no equal number of sigma and pi bond. That's why it's not the answer. XiO2F2, that can be shown in this way. And here if I talk about sigma and pi bond, 4 sigma bonds while 2 pi bonds. This is not the correct option. Further, SO4 2 negative. So that can be shown in this way. This way you can show that. It also does not contain equal number of sigma and pi bonds. 4 sigma bonds we can clearly see and 2 pi bonds. That's why it is also incorrect. So only one option is there that's correct. It is CS2 given in option 1. After that, question number 55. If the enthalpy of fusion of compound at 127 degrees Celsius is 36.2 kilojoule per mole, then the entropy change for the fusion is, the melting point of the compound is 127 degrees Celsius. So in this case, at melting point there is equilibrium, hence delta G for fusion is 0, or delta H for fusion minus D delta S for fusion is also 0. Enthalpy change for the fusion is given, that is 36.2 kilojoule per mole. That can also be written as 36200 joule per mole. Now we need to just find out the entropy change for this case. In this case, entropy change we need to find out. That would be equal to delta H for the fusion divided by the temperature of fusion, or simply you can say melting point. So this becomes 36200 divided by the temperature or the melting point for fusion of that compound. It is 127 degrees Celsius. In Kelvin it would be equal to 400. So I'll just divide it by 400 and it gets changed into 90.5 joule per Kelvin per mole. This would be the value. And where this value is given, this is given here in option 2. So just choose option 2 as your correct answer.